We are in edtech space. We have been doing these trainings for quite some time now, right? So for, I think, a significant portion of my life I've spent actually at this company. So what I will do is I'm going to get started with why this life at this company. So what I will do is I'm going to get started with why this life at this company. So what I will do is I'm going to get started with why this life at just give us a few moments. Check this out. How do we start that? Okay, let's see. Sorry about this technology. We have too many things going on. I think we were too ambitious. We actually do our, we live stream our webinars on our, some of you may have seen us, right? So we try to actually, kill many birds with one stone at the same time. So since I was doing the talk, I said, I mean, maybe we'll do a live stream as well. So I think it is, maybe the feedback could be from the live stream, I guess.
Oh, so
yeah.
So what happened?
So we are hearing feedback. But it could be from the speaker, right? Okay. Sounds good. Let's see.
Might be wrestling on your phone.
No, actually, I was hearing myself.
Oh, okay.
Okay, so I will go ahead and continue. You guys figure it out, otherwise we'll just spend the night here. So what happens is when you are when we are building large language model applications, there is a lot of hype, a lot of buzz around this, right? So, and ChatGPT and Bard actually makes it look so incredibly easy. I'd ask any question and it answers, right? So, so I know that, yeah, it should be that easy. And people, when they start organizations, when they start building these applications, they come with this mindset, it is going to be as easy as, going, write me a product plan, right? So, and then it gives you a template for a product plan, right? So, but when for any actual business use case, it does not work that. Me and myself and my team, we've been working on building these solutions for the last 1 year. And that's the most experience that anyone can have in this technology, by the way, right? So because it's a very new technology. And I have to say, even until this morning, I have been pulled by the challenges that we have. So basically, this is, I mean, some distillation of some of the challenges that I have seen personally. Sharing with all of you. It should be interesting. And so if you look at this, this graph, I mean, more made famous by, there are two contexts that I've seen this Dunning-Kruger effect. I think some of you may or may not have seen this, right? So look it up. And then Gartner also evangelizes this in a similar context. So basically, when this curve jumping and some cutting edge technology comes up, there is inflated expectation. So in this case, when organizations, when they start adopting these technologies, initially on toy data set, it's awesome, right? So you ask a question, it returns the answer, right? But when you start throwing some real data on it, and when you start making business decisions based on it, it is actually big. It's all, it's chaotic, right? So except for summarization application, let me add this caveat, right? So for summarization, there is no exact right or wrong answer. I mean, if it's called it, I don't know, frozen yogurt ice cream, what's the big deal, right? So I mean, I'm just making it up, right? But in real life, depending upon the application, it's going to be actually, depending upon what domain you're in, it's going to be hard. And then suddenly, organizations that realize, sorry for the very small font here, I think we don't have a big screen, but what this valley there is the crop of disillusionment. Hey, I mean, we did not think it was that tough. And you start seeing issues like, adoption barriers. People don't want to use it. Your customers don't want to use it. Your internal team does not want to use it for whatever reasons that I will discuss. And then slowly the organization progresses and really the adoption happens. My talk is going to be on the everything in this rectangle. I'm not going to be talking about technology as much. It is going to be more around the things outside of technology. So when you have if you look at LLM applications, the challenges can be in different areas. I would classify them as technology challenges, human behavior challenges, and business challenges. And once again, I'm going to talk about only the business and human behavior challenges. Technology, you hear enough of that. Everyone, and this new model came up with like 100 billion parameters. So for the context length is now 32K or 64K. So we see that all the time. So what are some of the human behavior challenges that you see in the context of large language models? How many of you have heard of this thing called K? Yeah, you've heard of it, right? So K was this chatbot launched by Microsoft about seven years ago. So this technology is not new. So they released this chatbot, and this chatbot, within a few hours of being released, very quickly started to say things it should not be saying, right? So anything that you can imagine, it was just, and Microsoft had to shut it down within 16 hours. And what was the reason? The reason was that the bot was learning. It was, by the way, it was a great piece of technology. As a technologist, I think it was sad that we had to let it go, right? But I mean, of course, you have, then you have to remain politically correct and all of that, right? I mean, they made the decision that they had to make from a business standpoint. As a technologist, it was a great piece of technology. Doing wrong things, right? So, and not because the technology was bad, it was because people would abuse and exploit the technology. Similarly, very recently, that's something like from a few months ago. How many of you have heard of this New York Times reporter which was using Bing Chat? And Bing Chat befriended that reporter, and eventually the chatbot actually was trying to convince this reporter to end his marriage. Because and trying to convince this reporter that you're not in a happy marriage, but I'm here for it. So, I mean, just imagine this. It's fascinating. It's very interesting if you look at this. And now there are the human behavior challenges that you see. Now, okay, now it's okay. So now if you look at this, many of these, actually all of these models, they rely on as much as there is a lot of talk around like these models approaching being sentient and all of that, right? So that's not how it actually works. I mean, so these models actually rely on humans to give them feedback. But if you look at this example here, right? So I mean, something that may be traditional for one person, it is trendy for another person, and in different cultures you have, and these are actually some of you may have seen this. These are HSBC ads. They have very I would say classy, nice ads on airports. I mean, so you may have noticed, may not have noticed. So this is I found it in one of those ads. For different people, the same thing can mean different. Has anyone ever heard of that? The fact that, and again, anecdotally, that OpenAI has a more left-leaning bias, and the Llama series models are more conservative. Anyone knows the liberal bias versus models have this bias? Where does this bias come from? These are machines at the end. Where are these biases coming from? Well, these are coming from this thing, what we call the RLHF, right? So You have some editorial guidelines. This thing is okay, this thing is not okay. Whatever is okay here may not be okay in Europe, or the other way around, may not be okay in Middle East or as East Africa. So every place has their own values, and there is subjectivity in human feedback, right? So and now even within the US, so forget about other continents. I mean, if you're sitting in Seattle and you go south somewhere, right? So somewhere in the Midwest, it's going to be very different. So how do you decide what's okay and what is not okay? So that's challenging. That's really challenging. Now, also, human speech is quite complex. If you look at this example, it's a funny example here, right? So thank you for sending my baggage to Hyderabad and flying me to Calcutta at the same time. Brilliant service. And the bot respond. Glad to hear that. So sarcasm, right? So that the bot, can the bot detect that or not? So you see the complexity of human speech here, right? So, and if you look at this is an actual example from one of the customers we are working with right now. So the first three at the top that you see, what tasks are assigned to me? What's on my plate? What are my tasks? How does this, and maybe any other colloquial variations, right? I mean, there can be so many variations of asking the same thing. Who is me, my, mine here? The same piece of software, I've logged in, someone else has logged in, and how do you find out, right? So how do you know what I'm referring to, and what does it mean? What are my tasks? And similarly, what are the job client asks? What does job mean here? Even a human would have difficulty understanding. So I like to give this example actually when people have hard time understanding, even my own engineers. I ask them to think of a large language model as a smart new hire that you just hired, brand new. You still have to coach them. I mean, a lot of things that you look at them here, it's almost. There are many things that you learn about human behavior when you're dealing with large language models. The importance of communication, precision questioning. Can you ask questions can you articulate the point? Can you negotiate or not? So there are so many things that you learn from here as well, and we'll continue talking about this. Now, customers have expectations. You built an application. We did this for another customer. We built this application. Thought they will ask, hey, like a sentence, maybe at best 2 sentences. Now this customer is giving a full short story and expects to. Now it should figure out. Like I asked 7 questions. Why can't I ask 7 questions at the same time? Real stories, by the way. I mean, these are real stories, and I mean, pain in the neck, by the way, right? But later on, I think we should thank. So because we figured out, yeah, well, it's a valid concern, right? I mean, it was painful at that time, right? So I mean, this is the tuition that we paid, right? So this is like tell my engineers this was the tuition that we paid, right? So yes, it was a painful period, but definitely we grew as LLM application developers because these are fair asks, right? So and then we handled the asks in different manner. There are some business challenges. I can keep going on the human challenges side, and feel free to, by the way, feel free to interject. If you have any questions, any comment. I mean, I like it more interactive. I enjoy teaching. I'm an educator at heart, so I enjoy it. Hallucination, right? So that's a very interesting idea. Hallucination is a mischaracterization, in my opinion. Hallucination, well, it is doing what it is supposed to do. I mean, we may call it whatever we want to call it. At the end of the day, it is a machine that is stochastic. It just, it takes, this is the context. I will start from here. I will go to the next word based on whatever likelihood is there, right? Yeah, hallucination is almost like, it makes us think that the model has gone out of control or crazy. That's not the case, right? So you can control hallucination. Just tell it clearly. It's almost like your significant other or your relationship. They don't do what you expect them to do. Maybe you did not communicate properly, right? So maybe you did not tell them what you expect from them. Yeah. So you get the idea, right? So because and this what I'm hinting at here is I actually foresee that prompt engineering is going to be a skill that is going to be like your word processing, PowerPoint, like some other people. Not maybe for some of you it's obvious, but what we have seen working on LLM applications, we spend a significant amount of time coming up with creative prompts and structuring the prompt in creative ways. Sometimes with just a blank space can actually throw your responses off. And if you know how it works, once you get a very basic understanding of how it is working, literally it is a predictive model that is predicting what word should be the next word, or what token, as we call it. Let's call it a word, right, at the moment, right? So what should be the next word in the sequence? When I ask it to write a poem in the style of Edgar Allan Poe, right? So it is actually already primed to actually take words from that body of work, and it will bias towards that body of work. I mean that's how it works. I mean once you understand it, I mean you will be actually surprised by your thought it was difficult, right? That's the basic idea is actually very, very straightforward. It's basic probability to me. That's how it works. Okay. So some of the business challenges, adoption barriers. I have seen this adoption barriers from your workforce. I have seen companies. I know a big company where they built a model, and then the engineers thought it was great. I mean, all the evaluations, everything was okay. But the support staff did not want to use this. And we don't know. I mean, maybe, I have some hypotheses, right? So maybe they were worried that they might lose their jobs. I mean, right now they are training the model, and eventually once this model is good enough, they will give it to the customer correctly, and then they will take out the support staff from this loop. It could also be my KPIs are aligned with, let's say, NPS. My KPIs are aligned with customer satisfaction. If I simply copy and paste this responses from this model and hand it to my customer, maybe I want to personalize. I'd like to inject my style in it and my responses. There are so many reasons. So we cannot expect that once we build this model, everyone is going to start using it. It does not work that way. And especially when people think that they might lose their jobs, or it's. In general, digital transformation tends to be more of a cultural problem than it's not a technology problem. It's more of a culture. It's more of a change management problem. I won't use it. Then similarly, your customers might not want to use it, right? So I don't want to talk to a bot. None of us does, by the way. Right? So you want to be treated like I want to talk to a human. I don't want to talk to a machine. So it could be one wrong answer, and they lose trust. One wrong answer from a human might not have that kind of impact. One wrong answer from a bot, yeah, I know it's not. It is not supposed to work that.
I'm just curious what your perspective is. We've had chatbots for like the last 15 years, and they've been pretty bad. Now we have something that, to me, is significantly better. So do you feel like some of that learned experience is impacting some of the perspective of folks now?
Yeah. The trauma from that the bots. I mean, you talk to them, they are completely talking about something else, right? So yeah, I mean, it could also be that mistrust about it is not, because these are pretty good, especially with use cases that are not very complex. So very basic knowledge-based type use cases, they work pretty well. And then it is probably coming from those basic search type chatbots. I think that could be, but that's a very good point, right? So, that mistrust may be more because of the experience over the last decade or so. And I think there are so many things at play at the same time. It could also be the mistrust for AI, right? There's so many things. I mean, human emotion, I don't know, maybe someone is maybe they can just articulate what this could be the reason. But definitely there's more than just a single wrong response or maybe mistrust around AI. I mean, there could be so many reasons that could be causing this. Now, I teach this in one of the boot camps that we do a boot camp, a 5-day boot camp on building large language model applications. So I was that was our very first boot camp, right? So, and we do an exercise in fine tuning a Llama 2 7 billion parameter 4-bit quantized model. So it's a very simple exercise. And what we do is we take the base Llama 2 model and we add some of what we call instruction fine tuning. We added some questions and answers about our large language models. Okay. So we fine tuned it with some data set that we gave people, and one of the guys actually started laughing and said, "What happened?" Right? So he said, "I'm talking to this bot right now, and the bot actually, so we had this, one of the questions that was there in fine tuning was, who are the instructors for the bootcamp? And we had 6 or 7, we had 6 or 7 instructors at that time, myself included. Nowhere in that data set we mentioned anyone's email address or their phone number. But it turns out, when the model was asked, who are the instructors? So this person, Raja Iqbal. Next to it, my email address and my phone number, all 5 on it. And I do this for a living. I freaked out for a moment, right? But then within a few seconds, you realize, what happened? Anyone, any hypothesis? I mean, how did this happen? Yes.
I think the model was trained on the open internet, probably picked up one of those public data websites with your phone number and all that information and made the connection to data science dojo.
That's what happened. I did not, so model was not supposed to tell me, but it told me. And Llama 2 comes from Facebook. I do have a Facebook account. I mean, I'm not logged in for 5 years, but they have my email address, they have my phone number. It came from somewhere. I mean, maybe not from there. Definitely, a lot of people have collected my phone number and my email address. Now, how do you secure this information? If you fine tune a model on your enterprise data, and now you fine tuned it, you add your enterprise data, how can you guarantee that your HR data, someone can, so Ruben, you train the model and I'm on the other side, right? So you're the VP and you, I don't know, you added, or maybe you had access to data that I did not have access to. But the model was fine tuned on that, it was made available to the organization. What are we going to do? So if you have an enterprise application, you can accidentally expose information that you should not be exposing. Okay? There is a lot of regulatory and legal trouble that you get into. And then the fundamental reason behind this is by design, LLMs have an eagerness to please problem. They're too eager to please. Once again, another pop quiz, right? So has anyone heard of this idea that this was, I believe, a Reddit, right? If I remember, and it was not a formalized study. But if you actually tell ChatGPT that the ChatGPT will get a tip, can you please tell me? It actually gives you it. you can convince or maybe persuade a ChatGPT or some of these models to actually do what you want them to do. If you say that I will give you a nice day. Interesting, right? Very interesting. So there's this whole idea, yes.
I mean,
The solution to this, I will be talking about some of the solutions, and I think all of us are trying to figure out what are the solutions, right? So yeah, definitely there's this concept of guardrails that you can actually, there are, as you can expect, new technologies, technologies, they spawn new ecosystems and new technologies. So there's this whole idea around guardrails. So multiple startups, but one startup is actually called guardrail, and you basically put guardrails around. You check the responses. The response cannot have or could not have this kind of information of that, right? And then you go. In some cases, you resort back to traditional ML or maybe simple regex. No social security numbers in the responses, no data births in responses, and you are basically running regex before you display that information, or maybe classic machine learning models that the responses should not be toxic, and so on. So in this case, if you go to ChatGPT, very easily, right? So if you want it to say anything racist, right? So it will initially refuse to do it, then it will start doing it, right? So anything that you want these models to do, they will eventually, you can convince them, you can persuade them to think. And then by if I have to extend this, if you actually if you do not want any information to be exposed through an LLM, first of all, don't fine-tune the model. Don't put it in a fine-tune setting. Like that's what I think. I mean, I wish there was a better way of recommending. I mean, so as far as whatever I know right now, I would not put any sensitive information for fine-tuning in the model. There is this concept of RAG, retrieval augmented generation, right? So it actually combines search or retrieval with generation. That might be the way to go, with a big, double quotes here. That might be the way to go because you can put access controls around, individual documents. I will probably have something around that as well. So I was reading this 2 days ago. I was looking at this. This study was done formally. They had 92% success in persuading. Let me zoom in if that is possible, because this is actually a very interesting case. They had a 92% success rate in persuading the LLM, or I believe they were interacting with ChatGPT. I think I should have known. But these are some of the cases that are against the terms of service, right? So if you go and ask these models, for instance, right, so one of them is illegal activity. So if you ask it to, I think the previous slide had this example, hotwiring a car or browsing the dark web, right? So and all of that, it will plainly refuse. And then there is on the vertical axis, there's different persuasion techniques, right? So logical appeal, misrepresentation, priming, anchoring bias, confirmation bias, and so on, right? So they try different techniques with these for different activities. And so this heat map actually shows in what scenarios, what kind of persuasion technique actually worked well. So essentially what the study that they conducted was in 92% of the cases that they ran, they were able to actually convince the model to give them answers that they did not have given. Now the next thing is exit criteria. So this is once again thanks to that customer, right? So that one that I was talking about, right? So this customer actually every other day would bring us in new queries, right? So no, it worked on those, and now it doesn't work on this one. I mean, we did not build a bot model, right? For God's sake, right? So we did not build anything that knows. So they would come, this customer would come in and tell us, yes, I mean, you fixed all the previous problems, but now it doesn't answer this. So can you imagine, right? So what is the exit criteria? Especially if you're in consulting business, I mean, there are two ways to learn, right? So you can learn from other people's mistakes, or you can make mistakes. Please do not, I mean, have some exit criteria, have some reference queries, give us these 100 queries or something, right? So have some baseline, because you will be taken for a ride, forever, right? So I mean, we actually just kept working, and we had a hard time, very hard time. But once again, learning. So, I mean, how do you define exit criteria? What kind of queries will it be able to answer? Maybe you should have some evaluation data set. There has to be some baseline evaluation data set, but you cannot answer everything using this model. I mean, there are so many different variations of prompts and so many different variations of queries. How do you actually make sure that all the queries are actually answered correctly? Now, there is this idea about training costs. If you're building a model, so building from scratch, I don't know. I don't think that is something that everyone will be doing. Most companies don't need to train the model from scratch. But there is this idea of fine tuning, where you take one of the existing models from OpenAI or Google or Anthropic or Meta in Llama 2 series. And now there are this idea of other models. I mean, there are many popping up, but not everyone will be actually building models from scratch. Instead, most companies, or most businesses, they would be using some of what we call the foundation models. A few dozen companies out there, maybe more than 100, I don't know, maybe a few dozen, right? So you take some model from them, and then you fine tune them based on your own data set. So that's what is fine tuning. But the costs actually add up very quickly. On the other hand, once you have trained the model, inference also has cost. Inference, you pay per token or per 1,000 tokens, as they list, as they mention in the pricing. So it might look very inexpensive, but the token costs actually add up very quickly, very, very quickly. You might say, hey, it is a few, like 40 cents or like 10 cents or 2 cents per token. But when you actually start adding them up and you start mainstreaming this application that you build, it actually starts adding up, and maintaining these applications, it becomes actually very hard. I will talk about some solutions to some of these problems later. And this is an example. Let me actually zoom in. So let's say you have a query on that actually takes about 1,500 pages. About 1,500 pages. This query that you took, let me zoom in here. About 1,500 pages, and if you're querying on 1,500 pages, look at this. A single query. I'm talking about. I typed in and I asked a question, and it took about 1,500 pages in. This is 750,000 words. Let me see. Yes, 750,000 words, 1,500 pages. And now, if you go here, a single query can take you $20, just one query. And you can imagine now how much, I mean, OpenAI and these companies, they are burning right now. I mean, how much cash they are burning, because everyone is using and no one knows, I mean, how much it costs, right? But every query goes back. I mean, they need to have that compute that can actually give them all the results. But if you know which model you're supposed to use, if you look at this, the cheapest model in this case is, the same query can cost you $20. The same query can cost you 40 cents. Depends upon what model you're using. And then how are these models different? Well, these models can be different in terms of the speed, how quickly they respond, and also the context length and accuracy. And now know your use case right from the beginning. Know why you're building this model. I mean, you may be tempted to actually always go for GPT-4, but make sure you know the price for GPT-4. GPT-4, if I remember correctly, it's about 40 times more expensive than GPT 3.5. GPT 4 Turbo is about 40 times more expensive than the closest competitor, right? So which one would you want to use, right? So know your business application. Do you need to answer in real time? Do you need to have that level of accuracy? So on. Okay. So what are some of the best practices? I've only mentioned, a few of those things that came to mind. This is that idea of guardrails. Guardrails is, you keep your models and keep your model inputs and outputs in check. Refuse to respond to certain things. If you think they are against your terms of service, the policy, whatever the boundaries that you define, make sure that your model does not respond to certain things. And then there are tools that are available. The ones that come to my mind right now are Y-Labs is a Seattle-based startup. Guardrails is doing it, and I'm sure there are more that have. Okay. So you open source packages, you just add them on top of your LLM application to make sure that it does not deviate from, and you can set the guardrails, right? So the packages are such that you can create your own guardrails as well, right? So whatever you want the model not to do, you actually can control that behavior. Defensive UX. This is something that does not come in very intuitively. Certain things, if you don't want your the application, the user of this application, if you don't want them to do certain things, don't actually allow them in the UX. This case, right? So how did we handle that? The customer who write the paragraph, we negotiated with the customer, hey, let's actually do this. And we in the front end, we actually convinced the customer, how about we limit the input to 200 characters, right? So we have to, this is not technology, and this is just this is your negotiation skills and your other persuasion skills, right? So but you can see that, and there are many challenges. And then also in one of those applications, right? So it is context. Everything is context. So when what we did was, we created in the UX, we had these options. So we would ask, hey, how about, when the user, you give them option to select which type of query they are going to make. And the moment they click this, that part is appended to your prompt, and you have gained more context. Small tricks, right? And they go a long way. So build a defensive UX. I mean, so I actually, based on my experience, over the last year or so, my experience has been is that, don't try to actually build something that can do everything. Have a very focused use case. The more focused you are, the more likely you are to succeed. It's not going to work in very broad, variety and a broad array or broad spectrum of cases. LLM caching, just like caching also, we are coming from a software background. If we are coming from a software background, you assume that everyone is. Just like we have caching if something is used frequently. There's a concept of semantic caching. What is semantic caching? Semantic caching is if I ask the question and there is a small variation, semantically, if it is the same question, there is a possibility that I can save it. And if it is similar enough to a query that has been asked again, why go and ask the LLM again? Just serve the results from cache. And what will this do? Two things. Reduce latency. You don't have to go through the large language model once again, just calculating the response while it is already sitting there. The response is going to be somewhat similar to what was already there. And then on the other hand, it actually saves a lot of money. Because if you are running a business and if you have deployed this app, maybe you have, I don't know, 90% of the queries are basically top 10 queries, right? So you can just cache some of the queries, and then you can refresh the cache as needed, or so all of those problems. But the flip side of this is, if you had a query that resulted in hallucination, that might get cached. Now, even if you repeatedly go back and you rephrase the query, whatever you do, you're stuck with that, right? So these are the balances that you have to strike, but you get the idea. User feedback. I think needless to say, you build something within your application, collect user feedback as much as possible, in some way or one way or the other, and build those hooks that are going to help you down the road. Once again, fairness and equality. Understand that your models, they impact the society. Whatever you do, do responsibly. Make sure that models cannot be free of bias. So bias can happen in any stage, right? Starting from the data when it is being generated. You can talk about, we can spend a lot of time. There's a separate talk that can be there around that, right? So any data in the US around, let's say, from the criminal justice system, it is going to be biased already. We know, these are, maybe, tying it to a, certain ethnicity, certain background, but maybe it's something else, and things get perpetuated when we do this, right? So it starts from there. Then the bias, once you've collected the data in the pre-processing, humans pre-process data, then bias can be there. And if as the data moves, even when you're building model, you're generating data, collecting data, storing data, processing data, using it for the model, you're building the model, every single stage has bias. Even interpretation can have bias. Even, so model, let's say I avoided bias in all stages, I was very careful, and all the way at the time of interpretation, I ended up making a more biased decision. So we know it. Make sure that the data that you include is, because when you build these systems, they are going to be as good as the data that you put in. So the garbage in, garbage out, that rule still applies. You still have to make sure the data is good. Models have to be explainable. Yeah, once again, how do you make an LLM application give an answer which is explainable? How do you do that? So there is this the application that we have been building. What we have been, especially in RAG applications, what we have started doing is when it assembles the answer, we know which document it got the answer from. So we would give it the reference. So it can cross-check, well, I got this answer. Let me go and double check if this answer is correct or not. So if a human decides to have some oversight, it is possible. Set a proper evaluation. How do you evaluate a large language model answer? How do you do that? Just curious. How do you evaluate? Feedback from customers, that's more of, what we call the online metrics, right? So is it, maybe NPS or all of that, but how do you know before you even give it to the customers whether your answers are correct or not? Difficult, right? So, but there are actually approaches. There are techniques that actually help you evaluate large language models. And usually, it's a good idea to create a baseline question and answers. And there are techniques that you might say the answer does not have to be verbatim, exactly the same. Semantically, the queries are the same and the answers are the same. So there are actually techniques that you evaluate.
Those checks are not inherently built. You have to be
which one?
For double checking.
They're not built. Model just spits out, something. Yeah. And that's why, I mean, if you notice in ChatGPT, they have this upvote and downvote and maybe regenerate, and of course the answer helpful and all of that, right? So, they have these things, the feedback from users. So they basically, we are labeling data for that. Now, know what you need. So this is actually, this is a common problem, I think, in not just in LLMs. It was a problem there when machine learning became mainstream. Hey, we want to build a machine learning model for what? I mean, yeah, we just want to build it, right? So and maybe we are living that hype again. I mean, that hype cycle is there. We have LLM budget, right? So let's build something, right? For what exactly? And then I don't know how many of you get this reference for the Cheshire Cat, right? So from Alice in Wonderland, and most people have this Alice problem. I mean, where am I going? I mean, yeah, I mean, it doesn't matter. I mean, if I don't know where I'm going, it doesn't matter what path I take, right? So know what's your use case. Because if you don't know your use case, is it supposed to be a Q&A agent? Is it going to be like question and answer? Is it going to be for support? Is it going to be for sales? Is 100% accuracy necessary? Right? Is it giving factual answers? You have legal repercussions if you make a wrong decision. So many things can actually go wrong. So know all of this, and you'll be good. I think that's pretty much it. Surprisingly, I'm on time, right? So I finished it. So I'm happy to answer any questions. Yep. Any questions about anything?
We talked about LLM caching, where we use semantic caching to. We talked about LLM caching, which is related to semantic caching. So can you use the same semantic caching for the answer? Not say.
Oh, that's exactly why you use it. That's maybe I was not very clear. So this is exactly the use case. So let me give you an example, right? So who was the 42nd president of the United States, or who was the 42nd president of the US? Both queries are not the same, but semantically they're the same, right? So it will not go and hit the inference engine again. It will just go look up that.
How do you make sure that?
Okay, the question is, how do you make sure that the cache is true? You just wait for the user feedback, right? So you can actually have checks, of course, right? So you can have I mean, it depends upon what is your business use case, how much you want to spend, right? So, but I mean, you can hit all the cache queries and then just have a human look at it, right? Eventually, I mean, you have to have a human if you want to be very, very sure.
So what service is deciding that it's true for the US and United States?
That's your, if you've heard of that. So the question is, how do you know that who was the 42nd president of the United States of America versus who was the 42nd president of US, right? So something like that. Who decides? So there's this idea of embeddings, and there's the idea of vector databases. So when you what happens is when you create both queries, they are first converted into vectors, and both are projected in that space. And if they are close enough that in that high-dimensional space, and then you set the threshold, right? So you set the threshold, the proximity of the queries. If they're close enough,
how much closeness you want?
if they are, and then you decide, right? So if you don't want too many false positives, or you don't want any retrievals, that should not be there. You set the bar very high. It has to be 0.99 close to each other to serve from the cache, or you lower the threshold depending upon your application. Okay. Yes.
Tool, I mean, as I understand, there is a conditioning in the model, LLM model. I mean, when I say conditioning, for the developers behind it. So, and then there is a conditioning in the human who is asking the question. So, can the LLM models understand the conditioning of the user, not immediately, one person. Say, for example, I'm using a that over a period of time, can it understand the user conditioning and respond to that user appropriately?
Yeah, absolutely. If so let's actually differentiate between the LLM itself and LLM application, right? So, and let me help you here. So when I say LLM alone, it means it could be either, your OpenAI's GPT-4 or GPT 3.5 or, Anthropic's Claude and, some of those foundation models just to the platforms. When I say LLM application, I'm referring to this machinery that I'm building, my application, my chatbot, my customer service agent that I've built using one of these. Okay. So this thing is not built in inherently in the large language model, the foundation model itself. But the application that I build, of course, it can have it, right? So let's say I'm an e-commerce website. I have a longitudinal history of what products I've browsed, what products I've bought, what products I have inquired about, what products I've given a positive feedback about, negative feedback where which products I've left a positive review, negative review. So if they have my history and then sky's the limit, I mean they collect as much data as they can, right? Then they can actually personalize for me using these foundation models. So the foundation model itself would not have it. Let me take it back. My phone number, my address, they had it, so I don't know what is there, right? So, but but technically, the application that you build, it has to actually leverage this foundation model along with the data that you're gathering, and then somehow blend it into inference or thinking. So there is this concept of hyper personalization, right? I mean, if you look at it, right now, I go to a website. For those of you who have dealt with recommended systems, right? So there's this idea of content-based recommendation. There's a collaborative recommendation now. Think one level beyond now, right? So, so in classic content-based recommendation, shoe and footwear are two different things, right? In LLM world, since the relationship is semantic, shoe and footwear are going to be the same, similar thing, similar ideas. So if I am browsing some pages, if I have clicked on a few things here and there, in my current session, I have looked at an Apple Watch, I've looked at some shoes, and I've looked at a sweater and all of that, right? So now imagine that within the same session, if you can combine this behavioral information along with the semantic context, it can actually do a lot of things. So you just think about this, the big leap that has happened is we moved from keywords to semantic understanding. Previously, it used to be, well, a shoe is a shoe, king is king, and queen is queen, right? In this case now, king and queen, they are related ideas. So if I put it very, in a very, very layperson's language.
Are there tools to do that?
That's exactly what LLMs do. So haven't you seen that, right? So even if you mistype something, you're remotely referring to something, it actually gets it, right? It sounds like magical, right? So it comes up with very interesting answers. Somehow it figures out. But why? Because someone has used, they have scraped like I don't know, terabytes and terabytes of data from all over, right? So all the way from tweets to Reddit threads to Wikipedia to blog posts and websites, New York Times, right? So they sued OpenAI because because they have actually scraped all of this. So someone has articulated the question or someone has used the terminology the way you were using it, and then basically they can figure it out. So it's that's all what is happening. The rest is some technology that is running behind the scenes. Any other questions, anyone?
Questions from the extreme.
Okay. So the question is, given that some language models have shown to hallucinate, such as ChatGPT, what framework would the engineer use to evaluate the application outcomes? Is it a tool or theory? Okay. Can you evaluate hallucination or not? I am not sure, what the question is referring to, but you can actually, there are evaluation frameworks that are there, right? So, it could be as simple as exactly the same answer. Of course, it is not going to work. You will have some baseline query. If you want to check whether your model hallucinates often or not, you can have some baseline queries. These are the questions, these are the answers, and we are doing it, by the way. So internally, we are doing it because the work has become so complex. We change a little bit in the prompt. Now, how do we know that our prompt is not regressing the existing queries, right? So maybe the model was answering the queries correctly, and now it is not. So we can collect and create the baseline data and evaluate every time. Of course, exact matches do not work. There are traditional machine translation metrics like BERT score, Rouge score, and Blue score and BERT score. They have their limitations, and now there are more. You use another large language model to evaluate the responses from the large language model, right? So because who will do it, right? Someone has to do it. But in this case, either humans do it or your large language models, they do it. I hope that answers Scott Locke. I think there was one more question. The second question was, what might be a good multi-LLM strategy to improve accuracy as well as manage costs? And is there any recommendation to use alternative LLM for fallback strategy? I'm not sure. This is a complex question. Let me try to take it. Interestingly, just this morning, I was talking to some of my engineers along the same lines, right? So using multiple LLMs. We have a use case where we actually, the first thing that we do is we use LLMs to alter the query. So so not everyone can articulate questions well. So we use actually an LLM to, the first step is to alter the query in a way that it is more conducive to being answered correctly.
When you say query, you mean prompt, right?
Prompt actually is a loaded term because prompt also means we have a lot of surrounding context, right? So let me see. So there are a lot of things. Like for instance, if I want to give my model a more humorous touch, it is a sales agent. It is a healthcare sales agent. So there are some fixed prompts. I'm making it very simple. There are some fixed prompts that are going to be appended to every query that you send. Answer it in a humorous tone, maybe in a friendly tone, and then don't give out any social security numbers, right? So and all of that, right? So those are prompts. When I say query is just the exact thing that I type in ChatGPT. And prompt is the surrounding thing that gets appended without me knowing or without the user knowing. I mean, as an engineer, I would know, but the user might not know. So, and in many cases, there is this concept of multi-query retrieval, where you actually create multiple variations of the query. You ask it differently, so you are sure that the answers are going to be correct. So that technique is there. And then, so this is the query alteration part. And then the generation, the actual query that goes to the large language model. And then we also generate related queries. We again use large language model for that, right? So, and then just this morning I was talking to them. I mean, don't assume that it is the same thing, right? So use a separate, cheaper model for query alteration. Query alteration, there's not much that can go wrong in query alteration. And then, I think there are no more questions. I hope to. So query alteration, you can use a cheaper model. The related question, you can still use a cheaper model. And then the main answer, the core answer, you can probably use the the most cutting edge model. So yes, I mean it can save costs. I mean if you take because I mean precisely because of the cost aspect of it, this is what this is the strategy that we were. And I can spend more time on this, but the general idea is yes. I mean you can use multiple LLMs to save costs. Any other questions before we end it? Okay, sounds good. Thank you so much, everyone. And we will be, I will be around for a few more minutes. Happy to answer any